Hi guys, welcome back. Now we're going to look at practice problem C, displacement with constant acceleration. So first of all, we can address this question at the top here. Draw a dot time to show displacement of an object under constant acceleration. So what would those dots look like if it's under constant acceleration? And we know that they would get further and further apart each time. So we know that during acceleration, the distance traveled per interval increases each time. So it's the same amount of time between dots, but the distance it travels hasn't increased, so that's acceleration. All right, so let's look at this sample problem here. Now in this equation, we're going to use this equation up here at the top, okay? X is 1/2 VI plus VF times t. Now a lot of times we subtract the final and initial velocities. In this situation, we're actually taking the sum of those velocities to determine the displacement. Okay, so if we list our givens, car acceleration from rest, so from is VI 0 to a speed of 6.6, so that's a VF, 6.6 meters per second, in 6.5 seconds, so my time is 6.5 seconds. Find the distance the car travels during this time. So now we need our unknown. What is our unknown that we're looking for? And it is find the distance the car travels. So that is displacement is question mark. And we need an equation. So our equation is the distance an object travels is equal to 1/2 the initial velocity plus the final velocity times the time that change has occurred. All right, and so we're going to substitute and solve S. So we don't need to do any special manipulation to this equation because we're looking for the change in X, and that's what our equation equals. So we're just going to be able to substitute and then finally solve it out. So the distance this car travels is 1/2 VI, which is 0, plus VF, meters per second, and times the time it took to do that, 6.5. And running out of a little bit of room there, but I think you can make that out. And so then finally we solve the expression. So X is 1/2 6.6 times 6.5, and X equals, so we get our calculator, and we just do 0.5, what I like to do for the 1/2, times 6.6 times 6.5 equals. And you see we get 21.45, but we want to report to two significant figures because that's what's given in our problem. 2 is the first significant figure, 1 is the second, so 4 rounds the 1 down, so we just go 21 meters. Okay, and so this is using the equation. The change in displacement is 1/2 VI plus VF times t. This is the equation we would use given constant acceleration, knowing the initial and final velocities. Okay guys, we're still on practice C. I hope you've solved number 2. Number 2 is identical solution and work method as number 1. But number 3 requires something a little different, so I thought we'd take a minute to solve number 3. So start off by listing our givens. So our givens. Traveling at a speed of, sees a cat 101 meters away on the road. How long will it take for the car to accelerate to a stop? So it's going to a stop. So that means our initial velocity is 21.8 meters per second. Our final velocity is 0 meters per second, and exactly 99. So the displacement is 99 meters. Now, if you're not careful, you may make the mistake, like I did earlier, and actually solve this with 101 meters. So 101 meters is where the cat is. We want to stop the car before we hit the cat. So we're just going to stop 2 meters, which is about 6 foot in front of the cat. So that's close enough to the cat. So we got our givens. Now we're looking for our unknown. How long will it take? So that is time. So now we need our equation, okay? And our equation for this one is going to be the same equation we used earlier. Change in x is 1/2 VF plus VI times t. The problem is we need this equation to solve for time. Time is our question mark, our unknown. So we need to do some algebra to manipulate this and solve it for time. So what we're going to do here is we'll just do some algebra steps. And so we go over here, and I like to put this as the solve the equation for t. So solve for t. And so that the change in x is 1/2 VF plus VI times t. So we'll combine a few algebra steps here. So we're going to multiply both sides by t to get rid of the 1/2. So that goes away. Okay. Now we need to divide both sides, or excuse me, want this to equal t. So now we need to divide by VF plus VI. And what you do to one side, you want to do to the other. So that cancels. And that leaves our expression t equals twice the displacement over VF plus VI. And be sure you add those before you divide. So we got our guess method. We come down here to our final S, which is substitute and get an answer. So we're going to substitute in our numbers. So we go 2 times the change in distance, and the change in distance is 99 meters, divided by VF, which it comes to a stop, so that's 0, plus VI, 21.8 meters per second, equals t. And so t equals, so we get our calculator here, and we'll just simply go 2 times 99, excuse me, I think I did divide it, 2 times 99 equals, and it looks like I typed that wrong again, 2 times 99 equals, all right, 198, and then we're going to divide that by 21.8 equals, and we get this 9.081, so we want to go back to our problem. 99 only has 2 significant figures, so we want to report that to 2 significant figures. So 9 is my first, 0 is my second, so the 8 rounds to 0 to a 1, so we would report that as 9.1 seconds. Okay? So you see this example is using the same expression, but we've had to solve it for t, and that's a common problem that we have to do. A lot of times there is no equation that says t equals. There's some other equation that we're having to manipulate to solve for